Hello, in this video, we'll talk about the greatest common factor. I want to do that, and and, and here, so let's say you follow it and you find, for example, for this number, the prime factorization is 2 times 2 times 2 times 3, and you're interested in finding the highest or the greatest common factor here for these two numbers. Let's say these two. And the prime factorization for 36 gave you 2 times 2. Let's say times 3 times 3. An easy method, of course, is just to line them up and see what they have in common, right? It looks like they have the 2, they have the 2, and they have the 3, right? So it looks like it's going to be, let's change this to 2, let's do blue, 2 times 2 times 3, which is a 4 times 3, a 12. Alright, so if you have an example of 24x plus, let's say, 36, and you need to find the greatest common factor, and then now you know it's going to be 12. Then you have x here, and what's going to be left, which is interesting, you're going to see for 24 it's going to be this number here, 2, and for the other 36 it's going to be this number here, 3, because the ones with the yellow give us greatest common factor, and whatever is remaining, or the other factor, will lead to the product. So this is nice to show. It's always good to go back to prime factorization because it helps to strengthen the skills. And of course, you can always discuss that when we factor, it means 12 times 2. How do we find that as well? Is here 24 divided by 12 will give us a 2, and here 36 divided by 12 will give us a 3. All right. We can do more examples, but I think this is kind of clear. This is the method for it. The other interesting way as well to show, if you did sets, then for example, if there is a common factor, let's say look at let's say we look at two numbers, let's say 18 and 27, right? Number 18 here, we'll give it this one, so it's going to be 2 times 2 times 3, let's say 27, it's 18, let's fix this one here. Let's do 2 times 3, which gives you a 6, and times 3 will give you 18. Then let's look at 27 here. 27, 3 times 3 times 3. But if we're working in terms of sets, there is a 3 and a 3 common, so let's take this out and put it here to be common, right? So this is only to show if you did sets, or you're talking about sets, or students did sets, and you can show that now the elements of the set 18 which in prime factorization is this, and for 27 is this, and of course with the other matching, right, if we do let's see here, this and this, so 3 times 3 in terms of writing, the greatest common factor for 18 and 27 is 9, which means we need to move these other 3 inside, and let's get it from here. All right, so this is another presentation for the same work, but using sets to show that a number with its prime factorization can be presented as well with the set, and we can see whether these sets have something in common or not, or they have elements in common, or they are disjoint sets. All right, so if we do that intersection of the two, we can find this 3 times 3, which is 9. Let's also show, while doing this, that it's possible that you have, let's just say 15 and 16, right? Just 15 and 16. In terms of sets, they're not going to be connected, or they're not going to have a common elements, because 15 is just 3 times 5, and 16 can be 2 and 2 and 2 and 2, right? So there is nothing in common. All right, so the empty set is the intersection between these two. Thank you.